Hi everyone, this is Kavya from Edureka. Welcome to today's session on Kubernetes Minikube tutorial. For all of y'all who don't know, Minikube is a really important tool that is associated with Kubernetes. It is an open source tool that really enables you to run Kubernetes on your laptop or any other local machine. It can work with Linux, Mac, and Windows operating systems. So what it really does is it runs a single node cluster inside a virtual machine on your computer or your laptop. Okay, this is what in short and in simple terms you could describe Minikube as. So before we begin with today's session, I'd like to address the agenda. Firstly, there'll be an introduction to Kubernetes followed by an introduction to Minikube. Then we will talk about Minikube Dashboard a little bit, and then we'll move on and run an application using Minikube itself. Finally, we'll conclude this session with some tips on how to make maximum use of Minikube with Kubernetes. I hope the agenda is clear. Introduction to Kubernetes. Firstly, let us understand why do we need Kubernetes and what is Kubernetes. So in the recent years, containers have become the definitive way to develop applications because they provide packages that contain everything you need to run your applications. So containers basically contain the code, runtime, databases, system libraries, etc. All of that is packaged within a container. Kubernetes, on the other hand, is an open source solution for managing application containers. So with Kubernetes, you can decide when your containers should run, increase or decrease the size of application containers, or even check the resource consumption of your application deployments. Now, the Kubernetes project is based on Google's experience working with containers, and it is gaining momentum as it is the easiest and the most recommended way to manage containers in production. Now, applications can be installed in Kubernetes using Helm charts. Helm charts are packages that contain all the information that Kubernetes needs to know for managing a specific application within the cluster. So if you have to explain Kubernetes and orchestration in plain terms that people can at least begin to understand, the agreed upon origin is from the Greek meaning helmsman or sailing master. So Kubernetes or 𝐂𝐲 is an open source platform that automates Linux container operations. It eliminates many of the manual processes involved in deploying and scaling containerized applications. In other words, you can cluster together groups of hosts running Linux containers, and Kubernetes helps you easily and efficiently manage those particular clusters. So basically, Kubernetes, what it does is it eases the burden of configuring, deploying, managing, and monitoring even the largest scale containerized applications. It also helps IT pros manage container lifecycles and related application lifecycles and issues including high availability and load balancing. So now that we understand what is Kubernetes, so in short, you can say that it is an open source project designed specifically for container orchestration. Kubernetes also offers a number of key features, including multiple storage APIs, container health checks, manual or automatic scaling, rolling upgrades, and service discovery. Applications can be installed to a Kubernetes cluster via Helm charts, which provides streamlined package management functions. So if you are new to this container-centric infrastructure, these are some of the basics that you will have to know. So now that we know what is Kubernetes, let's go ahead and discuss some of its features. So there are many features. Here, there are only the most important features, but there are many features for Kubernetes. The first one that we'll be talking about is service discovery and load balancing. So in Kubernetes, you don't really need to modify your application to use an unfamiliar service discovery mechanism. Kubernetes gives pods their own IP addresses and a single DNS name for a set of pods and can load balance across them. So here I use the term pod. So what is a Kubernetes pod? This is essentially the smallest deployable unit of the Kubernetes ecosystem. More accurately, it is the smallest object. So a pod is the smallest object in Kubernetes. A pod specifically represents a group of one or more containers running together on your cluster. So what Kubernetes does, it gives pods their own IP addresses, which can eventually load balance across them. The next feature is storage orchestration. Now, Kubernetes allows you to automatically mount the storage system of your choice, whether from local storage a public cloud provider such as GCP or AWS, or a network storage system such as NFS, Gluster, Flocker, etc. The next important feature is automated rollouts and rollbacks. This is really important because Kubernetes progressively rolls out changes to your application or its configuration while monitoring application health to ensure it doesn't really kill all of your instances at the same time. Now, if something goes wrong, Kubernetes will roll back the change for you. It takes the advantage of a growing ecosystem of deployment solutions. Another really important feature is that it performs automatic bin packing. So Kubernetes, it automatically places container based on their resource requirements and other constraints while not really sacrificing availability. It mixes critical and best effort workloads in order to drive up utilization and save even more resources. The next feature that Kubernetes has is batch execution. Now, in addition to services, Kubernetes can manage your batch and CI workloads, replacing containers that failed if desired. So if any of your workloads fail, it will immediately manage it and replace it. Next important feature is IPv4 or IPv6 dual stack. The allocation of IPv4 and IPv6 addresses to pods and services are done by Kubernetes itself. The next feature is horizontal scaling. So you can scale your application up and down with a simple command and user interface or automatically based on the CPU usage. The last feature is self-healing. So Kubernetes restarts containers that fail, replaces and reschedules containers when nodes die, kills containers that don't really respond to your user-defined health check, and does not advertise them to clients until they are ready to serve. So basically, Kubernetes is designed for extensibility. It adds features to your Kubernetes cluster without really changing upstream source code. Now that we have seen the major Kubernetes features, let's move ahead and talk about some of its benefits. So there may be many reasons why people come to use containers and container APIs like Kubernetes, but it is believed they effectively all can be traced back to one of these following benefits that you can see on the screen, that is velocity, scaling, abstracting your infrastructure, and efficiency. So we'll talk briefly about all of these benefits. The first one is velocity. Now, velocity is the key component in nearly all software development today. The changing nature of software from boxed software shipped on CDs to web-based services that change every few hours means that the difference between you and your competitors is often the speed with which you can develop and deploy new components and features. In this way, containers and Kubernetes can provide the tools that you need to move quickly while staying available. The core concepts that enable this are immutability, declarative configuration, and online self-healing systems. These ideas all interrelate to radically improve the speed with which you can reliably deploy software. The next benefit is scaling your service and your teams. Now, as your product grows, it is inevitable that you will need to scale both your software and the teams that develop it. Fortunately, Kubernetes can help with both of these goals. Kubernetes achieves scalability by favoring decoupled architectures. The third benefit is abstracting your infrastructure. Now, the goal of the public cloud is to provide easy-to-use self-service infrastructure for developers to consume. However, too often cloud APIs are oriented around mirroring the infrastructure that IT expects, not the concepts that developers want to consume. Additionally, in many cases, the cloud comes with particular details in implementation or services that are very specific to the cloud provider. Consuming these APIs directly makes it very difficult to run your applications in multiple environments or spread between cloud and physical environments. Now, the move to application-oriented container APIs like Kubernetes has two concrete benefits. First is that it separates developers from specific machines. This not only makes the machine-oriented IT role easier, since machines can simply be added in aggregate to scale the cluster, but in the context of the cloud, it also enables a high degree of portability since developers are consuming a higher level API that is implemented in terms of the specific cloud infrastructure APIs. So when your developers build their applications in terms of container images and deploy them in terms of portable Kubernetes APIs, transferring your application between these environments or even running in hybrid environments is simply a matter of sending the declarative config to a new cluster. Kubernetes has a number of plugins that can really abstract you from a particular cloud. Let me explain this with an example. Now, Kubernetes services know how to create load balancers on all major public clouds as well as several different private and physical infrastructures. Likewise, Kubernetes persistent volumes and persistent volume claims can be used to abstract your applications away from specific storage implementation. Of course, to achieve this portability, you need to avoid cloud managed services, which means that you will be forced to deploy and manage open source storage solutions like Cassandra, MySQL, or MongoDB. Putting it all together, building on top of Kubernetes application-oriented abstraction ensures that the effort that you put into building, deploying, and managing your application is truly portable across a wide variety of environments. The last advantage is efficiency. Now, in addition to developer and IT management benefits that containers in Kubernetes provide, there is also a concrete economic benefit to the abstraction. Because developers no longer think in terms of machines, their applications can be co-located on the same machines without impacting the applications themselves. This means that tasks from multiple users can be easily or packed tightly onto fewer machines. Now, efficiency can be measured by the ratio of the useful performance or work performed by a machine or process to the total amount of energy spent doing so. When it comes to deploying and managing applications, many of the available tools and processes are somewhat inefficient. When discussing inefficiency, it is often helpful to think of both the cost of a running server and the human cost required to manage it. Running a server incurs a cost based on power usage, cooling requirements, data center space, and raw compute power. Once a server is racked and powered on, the meter literally starts running. Any ideal CPU time is money wasted. Thus, it becomes part of the system administrator's responsibilities to keep utilization at acceptable levels, which requires ongoing management. This is where containers and the Kubernetes workflow come in the picture. Kubernetes provides tools that automate the distribution of applications across a cluster of machines, ensuring high levels of utilization than are possible with traditional tooling. Now, a further increase in efficiency comes from the fact that a developer's test environment can be quickly and cheaply created as a set of containers running in a personal view of a shared Kubernetes cluster using a feature called namespaces. Now, in the past, turning up a test cluster for a developer might have meant turning up 3 machines. With Kubernetes, it is simple to have all developers share a single test cluster, aggregating the usage onto a much smaller set of machines. Reducing the overall number of machines used in turn drives up the efficiency of each system. Since more of the resources, that is CPU, RAM, etc., on each individual machines are used, the overall cost of each container becomes much lower. Reducing the cost of development instances in your stack enables development practices that might previously have been cost prohibitive. For example, with your application deployed via Kubernetes, it becomes conceivable to deploy and test every single commit contributed by every developer throughout your entire stack. Now, when the cost of each deployment is measured in terms of a small number of containers rather than multiple complete virtual machines, the cost you incur for such testing is dramatically lower. Returning to the original value of Kubernetes, this increased testing also increases velocity, since you have both strong signals as the reliability of your code as well as the granularity of detail required to quickly identify where a problem may have been introduced. So now that we've discussed Kubernetes benefits in detail, let's go ahead and talk about the Kubernetes architecture. So Kubernetes automates the lifecycle of a stateless application such as a static web server. Without state, any instances of an application are interchangeable. The simple web server retrieves files and sends them onto visitors' browsers. Because the browser is not tracking state or storing input or data of any kind, when one server instance fails, Kubernetes can easily replace it with another. Kubernetes refers to these instances, that is, each copy of an application running on the cluster, as replicas. A Kubernetes cluster is a collection of computers, which are referred to as nodes, and all the cluster work runs on one, some, or all of a cluster's nodes. The basic unit of work and of replication that we've already discussed is called a pod. A pod is a group of one or more Linux containers with common resources like networking, storage, and access to shared memory. Now, at a high level, a Kubernetes cluster can be divided into two planes. The control plane is, in simple terms, Kubernetes itself. A collection of pods compresses the control plane and implements the Kubernetes application programming interface and cluster orchestration logic. The application plane or data plane is everything else. It is the group of nodes where application pods run. One or more nodes are usually detected to running applications, while one or more nodes are often sequestered to run only on control plane pods. So now that we've discussed Kubernetes architecture, this is all you need to know initially. We will go ahead and talk about working with Kubernetes. Now, Kubernetes is a platform agnostic and integrates with a number of different cloud providers, allowing you to pick the platform that best suits your needs. Now, there are two different interfaces from which you can manage the resources on your cluster. The first one is using Kubernetes command line interface, that is kubectl. And the second one is Kubernetes web-based user interface dashboard. So we'll be talking about both of these a little bit in general. The demo part will be done in kubectl, and the dashboard will just look at how it really works and how to really access it. So now let's move to the next part of the session, Introduction to Minikube. So firstly, we must understand what is Minikube. As I've already mentioned in the introduction, Minikube is an open source tool that really enables you to run Kubernetes on your laptop or any other local machine. It can work with Linux, Mac, and Windows operating systems. Minikube, what it does is it runs a single node cluster inside a virtual machine on your local machine. So in other words, Minikube takes the vast cloud scale of Kubernetes and shrinks it down so that it fits even on your laptop. Don't mistake that for a lack of power or functionality though. You can do plenty with Minikube. And while developers, DevOps engineers, and the like might be the most likely to run it on a regular basis, IT leaders and the C-suite can use it too. That's the beauty of Minikube. With just a few installation commands, anyone can have a fully functional Kubernetes cluster ready for learning or supporting development efforts. But all you will need is you'll need 2 CPUs or more. You'll also need 2 GB of free memory, 20 GB of free disk space, internet connection, and a container or virtual machine manager such as Docker, HyperKit, Hyper-V, KVM, Parallel, Spodman, VirtualBox, or VMware. So these are some of the prerequisites. If you have all of these satisfied and installed, then you can get started with Kubernetes in a single command, that is Minikube start. So I'll be working on a Linux virtual machine, that is Ubuntu, and I'll be showing you some of the steps for you to install Minikube on a Linux using, binary download. Okay, so before we begin, we have to install kubectl and Minikube. So for installing kubectl and Minikube, there's certain set of commands that you will have to remember or that you'll have to execute. You can pick any of the commands based on any of the architecture or OS in the official website of Kubernetes. So to download kubectl, initially you'll have to execute the first command, followed by the second command, and then finally check if it has been successfully installed. Since I've already installed kubectl on my VM, I'm just going to check if it has been installed successfully. And you can see that you have the client version, you have the Git version, the Git commit, you have the build date, the Go version, all of that. So next thing what you're going to do is you're going to download Minikube. So this is the command to download Minikube, followed by install command. And then finally, you start the Minikube instance. This is really important, okay? So that's what we're going to do. Once the startup phase has finished, your Kubernetes client kubectl will have a Minikube context and will automatically start using this context. Checking what nodes you have in your cluster will return the Minikube hostname. So I'm just going to use the command sudo kubectl get nodes. So you can see that there's a node Edureka which is ready. And also you can view the Minikube version using the command Minikube version. Sorry, I just put an extra O. So currently we have the v1.20.0 version. So I'm just going to clear my screen. Now let's move ahead to the next part of this session and talk about Minikube Dashboard. Now, the dashboard is a web-based Kubernetes user interface, and you can use it to deploy containerized applications to a Kubernetes cluster. You can also use it to troubleshoot your containerized application, manage cluster resources, get an entire overview of applications running on your cluster. You can also create or modify individual Kubernetes resources such as deployments, jobs, etc. For example, you can scale a deployment, initiate a rolling update, restart a pod, or deploy new applications using a deploy wizard. Now, to access the dashboard, you simply use the command Minikube Dashboard, and this will enable the dashboard add-on and open the proxy in the default web browser. It is worth understanding and noting that web browsers generally do not run properly as the root user. So if you're in an environment where you're running as root, see the URL only option. To stop the proxy, abort the started process using Ctrl+C. So if you don't want to open a web browser, the dashboard command can also simply emit a URL, minikube dashboard -- URL. Now let's switch back to the VM and access the dashboard. So first what we're going to do is we're just going to type the command minikube dashboard. Now once the dashboard has been enabled, you will be automatically redirected to the dashboard page on your browser. So on top, you can see there's an overview button, and here you can see the workload, service, config and storage, cluster, settings, about, custom resource definitions, all of that. You can also see the workload status where you have deployments, the pods, and also the replica sets. Now to create an application, you can just click the plus button in the top right corner, and which will give you three options that says create from input, create from file, and create from form. Here you can specify the application name and also specify the Docker image that you want to use. So after all of that is done, you can just click on the number of pods, the service, and then finally you can click the deploy button, which will be presented with a new view that shows deployments and replica sets. And after a bit of time, you will also see a pod. So these are some of the key API primitives. So I'm just going to create from form. I'm going to type Redis, and also the container image will be Redis. Okay, and then I'm going to click on the deploy option. If you want to view the pods, you can just click on the pod option. If you want to view the replica sets, you can click on the replica sets option, and you can see the replica sets that has been created. You can also view the deployments by clicking on the deployments option. So we can switch back to the terminal now, and we can view all of this using the command kubectl get pods, -rs, that is replica sets and deployments. You can see that the Redis pod has been created and the replica set Redis has been created, and also deployment has been created for Redis. Now your Redis pod will be running the Redis server. So you can see that using the logs command. And I'm just going to copy this. So here you can see all of the information, that is the version of Redis. You can also see the running mode and the port that it's currently activated on, and if it's ready to accept connections. So with this, we have discussed what is the dashboard and how to make the maximum use of the dashboard. Now let's switch back to our terminal and clear this. So what we're now going to do is we're going to learn how to manage your clusters. You can pause Kubernetes without impacting deployed application using the mini pause command. You can also stop the cluster by using the minikube stop command. As the same way we started the cluster using the minikube start option, you can also stop it. Okay. You can also increase the default memory limit by using the config set memory command. Okay. You can also browse the catalog of easily installed Kubernetes service. You can do this by using the command sudo minikube add-ons list. You can browse through the Kubernetes services. You can see that the dashboard has been enabled, the default storage class has been enabled, also the storage provisioner has been enabled, and the REST ingress and log viewer, ambassador, autopause, all of that has been disabled as of now. We aren't using it. If you want to delete all of the minikube clusters, you can use the command minikube delete -- all. I'm going to clear the screen. Now, if you want to view the various commands in Minikube, you can just simply type the command minikube -- help, and this will list all of the commands that you can really use. You can see that there's the configuration and management commands like add-ons, config, profile. There are also advanced commands. You also have troubleshooting and debugging commands like describe, CP, authorization, which inspects authorization, and many other commands that you can use. We will now create a Kubernetes deployment named Hello Minikube using an existing image named Echo Server, which is a simple HTTP server with the port set to 8080 using the -- port flag in our command. So you can see that I have typed out the command sudo kubectl create deployment hello minikube image is equal to 𝐂𝐝𝐵𝐺𝑠.io/echo server 1.10. And it says that hello minikube has been created. Now to access the deployment, you will have to enter the command expose deployment. The -- type is equal to node port flag specifies the type of the service. So you can see that the service Hello Minikube has been exposed. Now to verify this expose, you just type in the command kubectl get deployments. You can see that it is ready and up to date and also available right now. Now that the deployment has been exposed, I'm just going to clear the screen. Now you can just use the kubectl get services command, and you can just check out all of the services that are currently running. Now, if you want to delete the service, you can just simply use the kubectl delete service hello minikube. And once that is done, you can see the services that are currently present and you do not have minikube in it. And if you want to stop minikube, you can simply type in the command sudo minikube stop. Once that is stopped, you can also delete minikube by using the minikube delete command. Now let's conclude this session with some tips that you'll require to use minikube. So once you have minikube up and running, the following tips can really help you get the most from the environment. First one is to sharing your Docker daemon. A Docker daemon is included with minikube. This is the same daemon you use for Docker only deployments and can be shared between minikube and Docker. Now, if you share, you can speed up your local tests and make any Docker builds you create available to minikube. The second one is using add-ons. Now, add-ons we already saw in the demo session. They're just the extensions of minikube that you can enable or disable to provide access to advanced features. Add-ons can enable features like the dashboard, registry, credentials, or ingress. You can also use add-ons that are already available, or you can use customizable add-ons by modifying the associated YML file. The last tip is to gain access to host files. Now, if you want to make files on your host system available to containers running inside minikube, you have a couple of options. First, you can use minikube's mount command, which uses a 9p file system implementation under the covers to expose host files to the minikube VM. Now, the minikube 9p mounts have some performance impacts compared to hypervisor native mounts and work best for directories with just a few files. As an alternative, some hypervisors automatically mount a host system directory and make it available for use inside the minikube virtual machine. Now, these special mount points that we're talking about provide superior performance to the user-definable minikube 9p mount points. So these are a good option if you need to expose a large collection of files to the containers you're testing inside minikube. Unfortunately, the hypervisor guest mount points differ depending on the host system OS and hypervisor you are using. So these are some tips that you will have to really remember when you're using minikube or when you're starting to use minikube. With this, we come to the end of today's session on Kubernetes Minikube tutorial. If you have any queries, feel free to leave them in the comment section below and we'll get back to you as soon as possible. Until next time, thank you.